In this video lecture, I will discuss PL/SQL triggers. Now, what is a trigger? A database trigger is a stored procedure that is fired when an insert, update or delete statement is issued against the associated table. The name trigger is appropriate as these are triggered or fired when the insert, update or delete commands are executed. A trigger defines an action that the database should take when some database related events occurs. A trigger can include SQL and PL/SQL statements to execute it as a unit, and it can invoke other stored procedures as well. Now, a trigger can be defined as a block of code that is attached to an event that may occur on a data table. When that event occurs, the trigger code is automatically fired. A trigger is actually a stored block with declare, optional section, begin section and end section, and it is always associated with a database table or some action. It fires automatically when certain data manipulation language statement or action is carried out on the table. The triggers can be before or after an event like insert, delete or update. A statement level trigger fires once for all the affected rows. A row level trigger fires for each affected row. You can understand the difference between statement level trigger and row level trigger in this way, that if a query is updating 15 rows in a table, then if it is a statement level trigger, then all the rows, 15 rows, will be updated at once. But if the trigger is a row level trigger, then every row will be updated individually. That means the row level trigger will be fired 15 times for every affected row. Now, trigger and naming. Trigger naming follows the naming rules of PL/SQL named blocks. You know that the PL/SQL blocks are anonymous or named, so the way you declare the names of the PL/SQL block by using the create or replace statement, in same way you can define the trigger. A trigger name must be unique in a schema and is a PL/SQL block with declarative, executable and exception handling sections. It is just like a PL/SQL block. The only difference is that it should have a name and that name should be unique in a schema. Triggers are independent database objects. Triggers are not part of a package. A package is a collection of related procedures or functions or blocks. So since triggers are independent, so they cannot be made a part of a package, and triggers cannot be local to a PL/SQL block. If you define a trigger, then it will be common to all PL/SQL blocks. Wherever that particular insert or delete or update DML statement is executed, from there the trigger will be initiated. What are the uses of triggers? The triggers are used in auditing your database. Auditing means storing information about sensitive data when some changes are made on a table into an audit table. So what you can do here is you can maintain your audit tables, and that means whenever some sensitive data is updated, these audit tables will automatically be updated by the triggers which are activated on the table where the changes are taking place, right? So it can store old and new values, and like user who did changes and timestamps. For example, if you have a table where you are maintaining the salaries of employees, and whenever the salary is calculated, you are actually storing the salary details in a transaction table, but you also want to maintain that who did those changes, so that will be like auditing. Then data integrity. Data integrity means that you want to make the data in the tables consistent. So for that you can implement checks on data against business rules, that if you have defined certain business rules, whatever changes are taking place in the tables, they should follow those business rules. Data integrity is implemented by comparing the already stored value and the new value being updated. If the data integrity violation is there, then the changes are not done, they are rolled back. If the changes are acceptable according to the business rule, then they will be implemented in your tables, that means committed into your tables. Then the referential integrity, it allows you to update foreign key values if primary key values is changed. You know that a primary key column can be referred into another table as a foreign key, and the values in the foreign key are always taken from the values that are stored in the primary key. So if some primary key value is updated, then using a trigger you can update the changed primary key value into the dependent row where it is referred as the foreign key. For example, if department ID is changed, the appropriately update the department ID of all those employees who are belonging to that department in the employees table and referring to the department ID from department table as a foreign key. So if department ID changes in department table, it should be updated into the employees table where it is referred. Then next uses derived data. If a column contains values based on calculation on another column, then it must be updated if the base column value changes. For example, if net salary depends upon the deduction column, and if the deduction is recalculated, then the net salary must also be updated automatically. Now this can be implemented by using the triggers, that if the deduction column is updated, then net salary column must also be updated or modified. Then next is ensure security. Logging of database access can be audited. Database access means that who are the people who are using their usernames and passwords to log into the database and access the data. So for ensuring security, you can log the user's data into the log tables, and it can be done by preserving date and time each user logs on, or denying access to certain users or at certain times. So if suppose a user comes to the office and tries to open the salary transaction table after 6 p.m., then you can define a trigger in such a way that if the system time is before 9 a.m. or after 6 p.m., then the user should not be able to get the data from the table or change the data into table. So this is where the trigger can be used. Then next is synchronizing multiple copies in a distributed database. Now distributed database is when the data of similar type is distributed at different locations, for example in an airline booking system. So you must want to synchronize the data stored at these multiple locations. For example, if you book your air tickets from a particular location, the air booking system must update the changes into the flight details everywhere, so that the people who are booking the tickets after this transaction, they must get the updated information about the flight status. Then last uses generating statistics on table access. When a table is accessed and by which user and for which activity, this statistics on the table access can be generated by using the triggers. So these are the basics about triggers. Next we will discuss the syntax and how the triggers are implemented.